Hello, everyone. Welcome to the second webinar section of the year 2022. It's a wonderful Saturday afternoon in Lagos, Nigeria. For me, I'm joining this call, and yeah, I'm spirited for an outstanding afternoon, especially with the incredible packages we have in store for today. My name is Precious Eureka, a data scientist at Hamoye Labs, and I'll be your co-host for today. I would like to welcome to the session, as well as our distinguished participants, the Hamoye Fellows, the alumni, and our incredible stupendous interns of the winter 2022 cohort of the Hamoye Data Science Internship. In the words of Jeff Werner, the CEO of Adlington, data really powers everything that we do. No wonder the algorithms learned from data are increasingly becoming decision-making and paramount factors across a whole lot of areas in our lives, including the movies we see, to the prices we pay or the medicines we get. Hence, we have the topic fairness in machine learning, a global perspective. The concept of machine learning fairness, or fairness in machine learning as it's normally called, it's a recently established area of machine learning that studies how to ensure that biases in our data and model inaccuracies can be handled for better results. It also checks that these models do not treat individuals unfavorably on the basis of characteristics such as race, gender, and disabilities. There's so much more to learn from machine learning fairness, and who better be the lead to this conversation than Wale Akinfaderin. For almost a decade now, Wale has been actively involved in mentoring early data scientists and engineers alike. He has served as a consultant to data science startups. He's created solutions to renewable energy, among other areas of our lives, and he currently works as a data scientist at Amazon Web Service. I'm sure we're all familiar with AWS. So it's a pleasure to have you join us, Wale. Happy New Year and maybe a happy Valentine too. Before we proceed with the presentation, please carefully take note of the following. First is feel free to make use of the chat box on Zoom and YouTube for comments, questions, and conversations around the topic. You can also use our Slido event code 2202. Again, 2202. And rest assured that all questions will be attentively answered. Then Ogogo form will be shared right away. This is to collect attendance for the interns. And also there's a secret code that will be pasted here on, should be used as an uppercase, and it will be available only for 600 seconds. Please also note that a second attendance will be opened later on at the section, and the secret code also be announced. So please feel free and do stay tuned. So at this point now, I'll hand over to Wale Akinfaderin, who will take us through the section. Please relax and enjoy. Thank you. Wale?
Yeah, thank you for the introduction, and thank you for having me, and happy Valentine's to everyone. So this is my Valentine's gift to you, which is fairness in machine learning, a global perspective. When I was thinking about what to speak, what topic, what the content for today would be, it took me a while to come up with this. I mean, there are a lot of technical stuff that I could have decided to talk about in this webinar, but I went for fairness in machine learning, a global perspective, for a lot of reasons, because a lot of people on the call are maybe fairly new to data science and machine learning. Some of them are actually about to begin the journey. But as you go on, you actually notice that there are a lot of misuse of this technology, that there are a lot of use cases, even in the global landscape, where there's some considerations, there's some things to be looked at when trying to build machine learning that doesn't mitigate bias. And so for this talk, I mean, I'm going to start by introducing myself. I'll introduce fairness in machine learning. I would start with an everyday example that you guys see, and then I'll talk about machine learning in global development. And then I'll talk about fairness considerations when developing a machine learning project. And then how do you build for fairness? And so those are the things that I'll talk about. I know it's a lot of us, but I would also like it to be a little bit interactive. So there's some cases where I would ask a few questions, and I would expect, even if you guys you don't necessarily need to talk, but just typing on the chat, I think that's good for me. Okay. Just brief about me. I'm going to be very brief here because of the timing, because I need to leave and go to a meeting at the top of the hour. So I'm currently a scientist at Amazon working on machine learning for healthcare. I'm a Google developer expert in machine learning. I've worked in the retail space and renewable energy. I did my doctoral research in spectroscopy. I'm interested in a lot of things, amongst democratizing machine learning for developing world, also responsible AI, and machine learning for low resource language. So I've been on a few committees. I was on committee for the machine learning for development for NeurIPS. So NeurIPS is actually the biggest machine learning conference in the world. And then also I've been a reviewer and also an ethics reviewer for the Association of Computational Linguistics. I'm a Real Madrid fan and I like playing Scrabble a lot. Okay, introduction to fairness in machine learning. The first example that I'm going to use to introduce fairness in machine learning is, how many of you know what Google Translate is? And have you used Google Translate? Just put yes or no in the chat box. Okay, that is good. So the first thing I want to talk about is machine translation for African languages. So Google Translate actually has a machine learning model at the back end. In most cases, it's called neural machine translation that actually takes a pair of data set. So it takes like an English data set and then a corresponding, for example, let's use Yoruba in this case, Yoruba data set, and tries and sort of build this machine learning model or neural machine translation to be able to build a model that actually translates from English to Yoruba, which is a West African language, or from Yoruba to English, right? Now let's look at Google Translate. Now, so I went there and I typed, she's a doctor, right? And so I'm actually Yoruba. And in Yoruba, I came back and gave Oje Dokita, right? Now, if I change the language, so I'm going from English to Yoruba. If I go from Yoruba to English, if I type Oje Dokita, what do you think it's going to give me? What do you think the English translation would be? Someone wants to type? Yeah, someone said she's a doctor. Okay. Any other person? She's a doctor, I guess. Okay. That's why you'll be surprised. Can you see? So if you go and you type Oje Dokita, right? It's going to tell you he is a doctor. And when I was preparing this slide, I was actually having a chat with my wife and I showed her. And the first argument that she came with is that, oh, maybe because sometimes the first person singular is probably E. Maybe that's why. But I said, hold on. Let's continue now and say, and type is a nurse, right? And in Yoruba, it's telling me nurse in it, which is, yeah, is a nurse, right? Now, if I take this nurse in it and do a back translation for it, I would not there a reverse translation, not back translation. So I'm going down from Yoruba to English. What it's going to tell me is that she is a nurse. Let me go back. is a nurse tells me nurse in it. If I now put nurse in it into it, it's actually going to tell me that she is a nurse. And so this is actually a perfect example of cases where you see sort of this gender bias and lack of fairness with which this algorithm is actually being built. So you see it, you can actually go and try this in your local languages. Some languages, they're pretty good, but some of them you sort of see how machine learning can perpetuate this bias. So the bias that male or men are meant to be doctors and women are meant to be nurses. And which is why every time we sort of build machine learning, we have to think about bias. We have to think about fairness. It's extremely important. Now, before I go to the next slide, one question I want to ask quickly is that what do you think is wrong with what I'm seeing on my screen? It's two questions, right? One question, actually, two options. Do you think it is coming from bias in the data set, or do you think it is from the model? Model bias in the data set. So any of the answers that you say, I think it's actually right. So the first thing is that there is bias in the data set. That's one thing you should know, especially if you're using a historical data set where typically the way that they've talked about doctors and nurses in the data set is like, because this model actually looks at contextual meaning, sort of semantic relationship between the different texts. So it could have seen that, oh, historically, this English to Yoruba translation document is always referring to doctors as men, right? And then nurses as female, right? So that is, when you have sort of this intrinsic bias in your data set. But then what your model does is that they actually alleviate this bias in your data set. So your model actually sort of increases this bias. So in most cases, it doesn't reach. I mean, there are ways to suppress and reduce it, but it doesn't necessarily sort of suppress and reduce it. So my next is that, so how do I define fairness, right? So bias is when you're trying to systematically favor a group from another, and you can measure it mathematically in most cases. But fairness is sort of very flexible, and it's a very subjective context that you have to evaluate it in the light of the circumstances and the goals of your machine learning project. So for fairness, it's like you're trying to ensure that every algorithmic decisions that your model makes do not create discriminatory or unjust impact when you're comparing across demographics. So it could be race, it could be sex. They're just different areas that you want to make sure that when you're comparing across the different demographics, you are not building models that would be unfair or unjust, right? So, and you could see an example of the machine translation that I showed you from arguably the biggest tech company, or one of the biggest tech companies in the world, where it's actually sort of perpetuating this inherent bias that we haven't. I mean, some of the finest doctors that I know, for example, are actually women. So I don't know why it has to constrain. And so that's what we're trying to tackle. Now, my next question is that I've given an example of this translation, right? Before I go to the next, okay, before I go to that, do you have like any sort of examples of like global development? It could be in your area where you think people are actually using machine learning, but there is some form of bias or there's a lack of fairness. If you just have any example, you can type it. Okay, none. I'll give you an example. Have you guys heard of M-Pesa before? It's called MPESA. If you've heard of it, just say yes. If not, no. Okay. Some people have heard of it. Some people know. Okay. So M-Pesa, Pesa is money in Swahili. So M-Pesa is mobile money. So if you think of, I think in Nigeria, there are a bunch of like mobile money systems. I mean, there's like the Naira and Paga and things like that. But M-Pesa is actually the first mobile money scheme or mobile money system in Africa. I think it was introduced in 2007. It's been in Kenya for a while. And basically, they've been using M-Pesa. So if you go to Kenya, you can go anywhere and just pay with your phone with M-Pesa. You can load your M-Pesa. It's at least I lived in Kenya for a bit, for a few months, and it was very seamless, right? Now M-Pesa, they started something called M-Shwari. So M-Shwari is now a mobile money lending system. So you can actually wake up in the morning, you can, depending on your credit worthiness, you can ask for some loan, and then you can go use that loan, do your business, do whatever you want to do with it, and then return it. So they have like interest, they have payback system, they have a lot of things where you pay back, you borrow money. So I was privileged to work with a few people that they were working with Mshwari data, and then they noticed that when they take loan, they always ask for loan late in the night. And in terms of defaulting on loans, men are actually more likely to default than women. And then women normally take loans in the morning. So maybe 5, 6, mostly before they go to market. And they actually don't default like men. And that was very interesting from the data. And then when they now went back, they now noticed that in terms of the lending system for the traditional banks in Kenya, when they lend people, sometimes as a woman, they would ask you to go bring your husband before they can loan you money. Now, if you think about that, who is actually more responsible? So just looking at the mobile lending data set, it seems like that shouldn't be the case. Maybe it should be the husbands that should bring their wife before they can get loans. Now, if you take this data, if these banks, for example, this traditional bank, they take this data and they try to use it to build some sort of algorithmic, mobile lending or sort of money lending model on it, the data is already biased because, for example, they're actually going to find out that if they're going to use gender as a feature, which I don't think anybody should use, then it's actually going to favor men more than women. But if looking at sort of this mobile lending data from M-Pesa, it actually shows that it's the other way around, that the women who are mostly market women and petty traders, they don't default, they pay back their loans quickly. And so those are some of the examples where you see people actually using sort of machine learning to sort of exacerbate the bias that you see, or the inherent bias from the data set. And then what the model does actually increases it. And so, so typically, any sort of real machine learning systems, you're trying to make some change in the world, right? So there's some context that you need to look at. And so some of the ethical concerns are demographic disparities, predictions versus interventions, accuracy, sort of diversity, and then stereotype perpetuation and some cultural denigration. In particular, I'll talk about prediction versus interventions, right? So let's say you're trying to build a model, and you take a model and you take two different groups, group 1 and group 2, and you decide that you are trying to interview them. So you're looking at interview performance versus their GPA, and you try to build, let's say, simple linear regression, and you draw a straight line between them, and then you see that it's actually favoring one group than the other, and then you decide that yes, I'm predicting that this group is what are the set of people that we should hire, right? And so that's where prediction comes in, and it's extremely harmful. And sometimes you actually need to think about it in the lens of intervention. So I can give you an example. Look at in advanced countries when it comes to people with disabilities, right? Sometimes when they try to think about what they can do and their performance, they think about it within the lens of, do they have the sort of the setup that can make them excel? So that's why sometimes when you're trying to write exams, they'll ask you if you have any disability, if there's some accommodations that you would need. And so you can actually do that for groups. You can ask that if there are actually accommodations that can make a particular group actually excel. So that's sort of where prediction versus intervention comes in. Okay, so this is examples of machine learning in international development. I'm going to, I have like a quick run through of a few cases where I've seen people use machine learning in international development. And as I'm talking about them, you can also think about this idea, this project or this landscape. What are some of the fairness considerations? What are some of the things that needs to be looked at when you're trying to build or develop machine learning for global development? So I've seen people use machine learning in agriculture. So there are some cases where people, I've seen a few teams where they'll put sort of a measurement system in a farm to measure soil quality, to sort of identify plant disease. I think the team at Microsoft and I think IBM a little bit, they did something like that in India and in Kenya, where they have this data set and they use machine learning to identify plant diseases. There are also some people that are actually connecting farmers to markets. A few people that I know, I think they're working in Uganda and Tanzania, they are sort of doing remote monitoring coupled with image processing. So the idea is that they're trying to use very, very high quality satellite imagery to provide agriculture insurance to farmers. And those are some of the agriculture use cases that I've seen. I've also seen a lot of stuff around education where people are using ML to promote literacy by sort of providing local content in local languages with real-time feedback. But also I just explained now about how this can also be harmful if you're trying to use a model to translate content and give it to local languages where inherently the data that you're using is sort of perpetuating a certain bias. Also, people have used it to use ML technologies to automate the process of assessing student performance. I've also seen people use it in jobs, interviews, which I really, really don't like. I don't think anybody should use machine learning to determine if someone should get a job or not. Is this person smiling? What's the facial structure now? I really don't like it. And then also some people are using ML to build sort of some catered content to make people learn more effectively. So these are some of the education use cases that I've seen. So in governance, I've seen people use ML to fill gaps in census data. and national surveys. So a lot of satellite imageries where I saw a team from Tennessee in the US actually use satellite imagery to count all the buildings in Kano, for example, right? So and sometimes you can also use this MR satellite imagery to have like a better understanding or a better identification of problems that you see at the community level and how to sort of allocate resources. Some people have used it to determine toxicity on social media. There was a project that I worked on a few years ago where I was using ML to digitize and analyze legislation and congressional documents. So basically, I looked at like the House of Rep and the Senate in Nigeria, in Kenya, in South Africa. I was trying to use machine learning to understand what's going on. So there's a paper that I wrote out there about it. I've seen a lot of huge use case in healthcare. There's a team called Ubenwa in Canada and in Nigeria where they're using signal processing and machine learning to improve bed asphyxia in low resource settings. So especially for small kids. There is a team, some of them in the US, Retina AI in Nigeria, and I think if someone in Rwanda, where they're using AI to diagnose diabetic retinopathy. So they sort of take microscopic images of the eyes, and then they use that to know if a person is diabetic or not. And also the bunch of using ML to diagnose tuberculosis from radiographs in chest. So a few teams, they've done that in Zambia and Tanzania. And I've also seen computer vision being used to identify fake drugs. So both computer vision and both NLP. So can you take an image of this is actually a really, really nice project. Can you take an image of so if you take like a drug or a medicine and take the image of it, and you have the image of the original, are there subtle differences between there that would make you identify if it's a fake drug or not? Or can you even do some form of NLP, natural language processing, on the image for you to determine, for example, is the NAFDAC code, so the Food and Drug Administration, is the code the right one? Can you quickly run a scan against a database to know if it's a fake drug or not? So yeah, so that's a cool project where people are using healthcare for development. And then this I've seen, and this is also one of the areas where I don't really like, where people, not that I don't like it, I feel like the way it is being done in some cases can be very predatory. So when it comes to loans, a lot of, especially in developing community or in underdeveloped nations, people just want to they basically want money to run their businesses, and a lot of companies, a lot of loan sharks, they've seen that as an opportunity for them to sort of make more money, and sometimes also they use machine learning to perpetuate some bias. So provide low interest microloans. I've seen people use ML to determine repayment rates. I've seen people also use it to determine credit worthiness. It is like you can use it, but it has to be done well. It has to be done such that you're trying to think about fairness when using machine learning for fintech in sort of a global scenario like this. Okay, so how do you aim for fairness in machine learning for international development? So there are 5 different key considerations for this responsible use of ML in international development. So the first is equity, representativeness, explainability, auditability, and accountability. And I would explain each one one after the other. So for equity, you need to ask yourself that, as your machine learning model being tested to determine if it's actually if it's disproportionately benefits or harm some individual or groups more than others. And I think that's a very good question to ask, especially at the beginning of the project. You want to ask questions about have you tested for example, one way to think about it is that I'll showing you the machine translation example, right? You probably want to know if the way it's translating, is it benefiting some individual more than the others? The other one is actually representativeness. So the data that you're using to train your machine learning model, is it representative of the people who will be affected by the model's application, right? So, for example, you can say, I'm building a model for A, but I'm using for group A, but I'm using data for group B, or the data for group B is overrepresented, when I'm trying to build this model, but I'm also concerned about what my decisions would be for group A. So that's where representativeness comes in. The other part is explainability. Okay, quick question. Have you guys done classification, or are you still in regression? Okay, you're still in linear regression. Okay. Now, so the idea around explainability is, now let's say that you have like this vector of length D in this one-dimensional vector, and then you have a machine learning model, which in this case, some people will call it a black box. I'll call it an opaque box. And then you have your evaluation metric. So your evaluation metric, since you're doing regression, for example, it could be a mean squared error, or it could be a mean absolute error, or your RMSE or R squared, right? But sometimes these numbers, they really don't mean anything if you cannot interpret, right? But linear regression in some dimension is an interpretable model, because for every decision that your linear regression makes, right, you have the coefficients of the regression, or your weights, and this is very, very interpretable. So if you make a decision for one, it's actually making it based on this coefficient, this regression coefficient, or your weights. And so it means that you can actually you can interpret it. But there's some advanced models that you can use, even for regression. So neural networks, gradient boosting, that in some cases you have a problem trying to make decisions, right? So you could think of it. Let's say a doctor is trying to determine if someone has a disease or not, right? And then the doctor comes to you and say, okay, I've taken your data, your weight, your height, your cholesterol level, your this, your that. And the model says that, yes, you actually have this disease, right? But are you able to interpret? Are you able to explain in human-friendly terms why that decision is being made, right? And so that's where explainability comes into it. And there's been a lot of sort of platforms where there is a call for explainability, where people, for example, frameworks like the GDPR, you should be able to explain every individual predictions that you make. But explainability is one thing. So there are a lot of methods for explainability. There's something called SHARP, and there's something called LIME. And the ideas of these are they're called post hoc explainability. So after you've built your opaque box model, you can actually use this ad hoc explainability methods to to sort of do like a global or local explanation for your individual prediction. But sometimes also you really, really don't need complex models. And this article was written in 2019. When it was written, it was a little bit, it was it was a little bit controversial. So it was written, I think it was it MIT or Harvard Business Review somewhere. Is why are we using black box models in AI when we don't need to? A lesson from an explainable AI competition. So it was written by Cynthia Rudin and Joanna Radin. So Cynthia Rudin is a professor of computer science at Duke University. And our argument in this case is that when you're trying to build stuff like credit loans, the justice system, maybe some healthcare, why are you using neural networks and very complex models? And then you're trying to do some sort of hard work explainable technique to explain them. Why are you not using sort of this open box, simple models to solve these problems? Because you don't have to get into sort of the complexity of explainability. And then there was a lot of backlash, but now I think everybody now sees what she's trying to say is that sometimes simpler is better. And then can your model's decision making, the processes and the recommendations, can some external actor query it? Have you built your system such that every single decision that is making, someone can come in and tries to audit it and understand what it's doing? And then the last one is accountability, which means that are there mechanisms in place to ensure that someone will be responsible to feedback and sort of redressing harms if necessary. So I can give you an example of a company that I've seen that are to some extent accountable. So I think it was last year, 2 years ago, someone actually saw that Twitter has a cropping feature. So when you post images, let's say you post an image of two people, one image, two people on Twitter, you would actually notice that it actually shows you one. When you click on it, you see everything, but it crops to the most important aspect of the picture, right? And people started saying that in some cases, when you have, for example, a white person and a black person, it actually zooms to the white person and not the black person, irrespective of how the picture is arranged. And there was a lot of uproar, a lot of people talking about it. And then Twitter actually responded to it. One was that they removed the cropping algorithm that they had. So we post the picture, what you post is what you got. And then another thing they did was they tried to have like an open competition where people can bring ideas on how to build a much better cropping algorithm that is fair. And then they also started like a research group within Twitter that is for ethics and transparency. And they sort of research on things like that, and they bring it to the pub, and they publish it so the public can see some of the work that they're doing. And so this is an example where a company actually builds in mechanisms to make sure that they are responsible to feedback and they're being accountable when it comes to sort of addressing harms when necessary. There's some additional considerations that you also want to think about, which is relevance and value. So is the use of your machine learning, is it solving the appropriate problem? The costs, the predictions, are they justified? Is there value in whatever you're doing? Sometimes some of this question also helps you to define fairness. And then last one, fairness consideration in developing a machine learning project. So this is for every step, you actually need fairness consideration. So for when you have an ML project, when you're defining your problem, you need to ask questions around fairness. When you're building data collection, are you collecting enough data? When you're doing data, are you collecting enough data? Are you sure that the data you're collecting has enough representation from the different groups? Your pre-processing, your model creation, is there an inherent bias in the data? And is your model trying to sort of increase or alleviate these intrinsic bias? You're tuning your evaluation, even to your deployment, right? When you're deploying, have you actually built in a feedback mechanism? What if your model in production is seeing a sort of different kind of data entirely? Maybe there's a model drift or there's a data drift, right? Is there some form of feedback mechanism for you to know when to retrain your model, reevaluate your model in sort of this deployment phase? So at each step, you need to be able to consider fairness. And then how do you build for fairness? I mean, the first thing is you want to ask the right questions, right? So when you're using a machine learning model in decision making, you want to know if the right question is being asked, and also you want to know if a machine should be making this determination. And so there was an example in the US where they were trying to use historical data, and it's in the justice system. They're trying to use historical data and machine learning to build a system to know if someone is going to be a repeat offender or not. And that would determine if they should let the person go early. And then they found out that, I mean, you shouldn't really be using a machine to make that decision. And they actually noticed that the machine is extremely sort of biased against Blacks, for example, versus other races when they try. So those are some of the questions where should you really be using machine learning to make a decision? Asking that question is extremely important. And then another thing is sometimes in your data sets, you also want to mitigate bias. There's a lot of ways you could mitigate bias. So there's sometimes you want data augmentation. If you don't have enough data, you want to augment what you have. You want to reweight some of the features. So some of the features that would perpetuate bias, you want to reweight it or don't even use it at all. And then there are a bunch of methods around resampling. So do you want to randomize the minority class in this case when you have imbalanced data set? Or there's also SMOTs, which I think at some point you guys are going to do it. It's in your curriculum, which is this oversampling technique where you have imbalance in your data set and you want to oversample the minority class. Sometimes it's good, sometimes it's not good. It's good, it actually improves your model accuracy, but in some cases, you're also introducing a lot of noise into your model. And so how do you do sort of this model creation tuning, or how do you evaluate for fairness in machine learning? And so the first thing is this demographic parity, which is, can you sort of establish a small collection of some predefined groups and then require parity of some statistic of the outcome across this group, right? So you want to, let's say you're trying to look at stuff maybe across gender or across some race, and you want to make sure that there is a parity in what the outcomes across this group. So you don't want to say, I'm building a model and group A, my accuracy or whatever model I'm using is 60, but for group B is 90%, right? So you want to be able to establish sort of this demographic parity. Oh, I'm running out of time. And then equalized opportunity is you want to make sure that your positive rates are the same between the protected group and everyone else. And so, which means that you want to make sure that there's some adequate data that enables this true positive rates to be estimated and equalized. And then the third one is equalized odds, which is an approach that is very similar to equalized opportunity. But what equalized does is that it takes the true positive rate and the false negative rate, and it tries to equalize it between the protected group. So sometimes it drives the machine learning algorithm to sacrifice accuracy in order to sort of satisfy additional criteria of fairness. And then there's also counterfactual fairness, which is very new, which you want to make sure that the two groups or whatever groups you have, you actually want to make sure that they are guaranteed the same predicted outcome for this counterfactual fairness. And then, so I think I'll share this slide with you guys. These are some of the formulas for these algorithmic fairness approaches. So you have things around demographic parity, equalized opportunity, and counterfactual fairness and equalized odds. And then these are sort of more formulas that you guys are going to look at very soon. Outcome variable, predicted outcome, true positive, false positive, and all these classification formulas. And then in these cases, how do you address fairness and bias throughout the machine learning process? So your problem definitions, you need your data collection, your preprocessing, when you're even building your models and when you're integrating your model. So in deployment and maintenance, you want to be able to audit your model and also reassess whatever is going on in your model. And there's some pretty good references. MIT D Labs, they have a document on exploring fairness in machine learning for international development, which is pretty good. Zachary Lipton, as the professor at Carnegie Mellon, wrote model interpretability paper, which is pretty good. And then there's a textbook on fairness and machine learning, delimitation and opportunities by those three folks from Stanford, which is a really, really good book also that I've read most of it, really, really good. So these are some of the references, a reading list for people interested in sort of exploring fairness in machine learning. So thank you. Thank you. So what I'll do next is I'll probably take a few questions and then, yeah.
Thank you so much, Wale. That was a very resourceful and impactful presentation. We can't thank you enough for sharing this innovative knowledge with us. I'm sure some of us, or most of us, if I'm not mistaken, we got one or two. We learned a lot from this very wonderful topic. And I'm sure we all took into cognizance the fact that we should always ensure fairness in our models, especially when it involves decision making. So before we move into the Q&A session, I would like to, the Google form will be dropped very soon to people from our attendance. So I would like to state the code. It's called supercoder in lowercase. So let me spell it. SUPER with a space, then CODER, supercoder. So let's jump right on to the question section.
I'll probably take a few because I need to leave soon. But yeah, so I think Sandeepta asked that, do AI fairness issues that concern developers revolve around mostly data sets or algorithms or both? So I would say both. Both the data set and the algorithm. So that's why sometimes some people see, you get a data set and you just want to dive into the models immediately, right? So sometimes trying to check the data set, trying to see if there's some bias in the data set, I think it's extremely important. And then because what the algorithm does is that it actually alleviates the inherent bias in the data set. So I'll say both. In what cases should we keep features like sex, race in our data set for model building? In most cases, I would say no. a lot of, so that's a question from Aditya. A lot of the things that we build, we don't necessarily need these features. So I would say no. So I've seen people, there was someone that was trying to build a credit loan system for microfinance back in Nigeria. And they were using, I had to talk to the person. They were using things like tribe, right? Is this person Yoruba even as part of the feature, which is extremely, extremely dangerous, right? So in very sort of sensitive project, you shouldn't use it. But also the problem is that sometimes you don't necessarily need to explicitly use maybe race or sex for your model to interpret bias from a certain group versus the other, because there are also other features that are actually representation of this demographic. So my answer is no, you don't need to use them, but also you need to check that you don't have other features that could be representation of some of these demographic disparities.
Okay, so we have a question from Ayush Vema. He said, we have heard of bias variance trade-off, but your explanation shows that bias is the bigger problem. So should we focus more on bias reduction for our model or balancing both bias and variance?
Oh, okay, yeah. Yeah, you asked about the bias variance trade-off in traditional machine learning. But also remember that the bias in this case is different from what I'm talking about. In most cases, I'm talking about the sort of intrinsic bias in my data set. So this bias that Ayush is talking about is actually bias in terms of model complexity, right? So you have just think about your bias variance trade-off, where you have like a very sort of simple, not really complex model. So you could think of a data set that looks like it's quadratic, right? And then you draw a sort of a straight linear regression line across it. Now that's a problem, right? So that's where, if you have like really high bias, you can underfit your model, right? And then sometimes also you don't want your model to be too complex, because you get into sort of the high variance regime, where your training error is extremely low, but your test error is high, right? And so the idea around sort of bias variance trade-off is that you want to make sure that you don't have a lot of bias and you don't have a lot of variance. So you're neither underfitting or overfitting your model. So you want sort of that sweet spot in the middle. And there are a lot of ways for you to tackle the bias variance trade-off. So some of it, would come through you trying to do a regularization, for example. If you're building some tree-based models, like a gradient boosting or random forest, you want to make sure that you're pruning your trees, you're just trying to set your hyperparameters to make sure the depth of your trees are not that much. In neural networks, the dropout probability, early stopping. So there are a lot of methods that you want to make sure that you're not overfitting. And if you're underfitting, in most cases, you just need to raise the complexity of your model. I'll take one more question, and
okay,
then I have
last question from Jeremiah Zhao on YouTube. He said, I certainly see the equity aspect of fairness of machine learning being an important factor, but do you think we end up overemphasizing equity over equality? I think we often end up responding to these models with policies that heavily favor groups that seems to be unjustly biased towards racism.
Can you mention the last part again?
Okay, he said, I think we often end up responding to these models with policies that heavily favor groups that seem to be unjustly biased towards racism.
Oh, that unjustly biased towards racism. So I kind of understand. I'm trying to understand the question. So my guess is that the person is asking equity versus equality, right?
Quality.
And
Yeah.
I had the image where sometimes equality is you giving, where they were standing up, and you actually give them the same thing to stand on, and then the other two people are actually still not standing on, right? And then equity is where you're actually giving each an appropriate stool or an appropriate chair to stand on so that they can see. And so the idea, the one way that I think of equity versus equality is that you can think about someone that has a disability, right? Someone that is blind, right? If you think of equality, right, it means that I'm gonna set a question and I'm gonna write it out on a piece of paper and give it to everyone. That's equality, right? Oh, the people with disability, people that cannot see, it means they will not be able to like write the exam, for example, right? And then okay, then I'll take a Braille system and then I'll set my exam in that system, which means that, well, the people that have eyes, they probably don't understand what's going on there, right? And so that's where equity comes in, right? How do you sort of elevate the different groups based on some of the historical disparities that they've had to go through, or the sort of inherent injustice or inherent bias against them. And so that's where equity versus equality comes into play. I don't know if that example, if I'm able to explain. Okay.
Okay, that's great. I think because of time, we won't be able to continue with the questions. Just
Yeah.
so you know, yeah, we already have them documented, so we're going to respond to each and every one of your questions on Slido
Okay.
form shared. Yeah, so please take note on intents. We'll have your questions documented and responded to.
Okay. Yeah, sounds pretty good. I really enjoyed this discussion and some of the questions. I would just ask, I mean, I'm on Twitter, I'm on LinkedIn. You can send some of the questions. I'll try to get to it. Maybe not soon, but eventually I try to respond. But yeah, it's been an interesting session. Yeah, thanks everyone.
So thank you guys. Thank you for all attending today's webinar. It's finally time to call it a day. First, I would like to thank Wale Akinfaderin for taking the time to engage us in this very insightful webinar. Every second was worth it. I learned a lot personally, and I'm sure we all did as well. If not for time, I'm sure we have a host of questions to ask as well. So I also want to thank you all for being here today and the time to patiently listen to what he had to say. And I hope you gained some insight as much as I did. Thank you to the Hamoye team and to everyone who saw the success of today's webinar. It's been a pleasure being with all of you today and being your host. So do have a very, very good weekend. Bye-bye.
Bye.
Bye, guys.